54. All right, so lesson 54. The first thing we're doing is the substitution axiom. And we have been doing the substitution, at least part of the substitution axiom. By the way, axiom means what? Basically means it's a rule, right? All right, so here is one term that you have been doing. Although that's not a slash, it's supposed to be 2. Right? You've been able to substitute these for a little bit. Sometimes you get stuck on them, but for a little bit, you've been able to do these. Yeah. It's okay, you're fine.
So about 9:30.
All right, so the substitution axiom we've been doing so far, right? Does this look familiar? I just wrote out a whole problem, starting with x squared y over p, plug in the numbers for them, solve the problem, right? All right, so the substitution axiom goes like this. There are 3 rules you need to be attentive to in this axiom. Rule number 1. I'll try to simplify this as much as I can. Changing the numeral by which a number is named in the expression does not change the value of the expression. All right, so changing the numeral by which a number is named. So changing the letter does not change the value. All right? Named, that's weird. Does not change the value. All right. Now, rule number 2. For any numbers a and b, 2 different numbers. All right. 2. If a equals b, then A can be used for B. If A equals B, then A can be used for B. They can be substituted for each other. All right? And then to piggyback on that, if A equals B, if 2 letters equal each other, if A equals B, then A can replace B. Or B replace A without changing the truth or falsity of the statement. These are rules that you've been doing. We're just defining them. So basically, as long as A equals B, whatever you can substitute them back and forth, and you're not going to change the truth or the falsity of the statement. Which means we can do some stuff with equations that can get a little bit dicey if you're not paying attention. All right, so here we go. You ready for this? Let's consider 2 equations at once. All right? Okay, these are 2 equations. Let's consider these. 2x minus y equals 1, and x equals negative 3y plus 11. These are called simultaneous equations.
Plus 11.
Yep. These are called simultaneous equations. All right? All right, we'll see if these are simultaneous equations. We'll find out. Let's solve them. All right, let's consider these two. All right? So somebody solve me this one when we use 3, 5. So 3 for x, 5 for y. What is it? What do you get?
It's
1
true.
equals 1.
1 equals 1. What about this one? 5, 2.
True.
All right. Right, 5 equals 5 is what you should end up with. Now, do they now flip-flop them? So do 5, 2 for the first one and 3, 5 for the second one. Is it still true? Excuse me.
The first one's false.
Okay, so they don't interchange. But we can determine if there is a solution that works for both of them. The ones that are up there don't work for both of them. But using the substitution axiom, we can find out if there is. All right? This is where it gets interesting. All right, so we're going to use the substitution axiom. We're going to solve these equations by substitution. All right? So we're going to solve for x and y. A, B. 2x minus y equals 1. Remember, that's the first one. 2x minus y equals 1. And the second one was x equals negative 3y plus 11. All right, so those are our two. Okay, we're going to use substitution to solve these. All right, so we have to make an assumption before we can do this. First, we must assume that a unique ordered pair of real numbers exists that will satisfy that. We have to even attempt substitution, we have to believe that there will be an ordered pair that will solve those two. All right? And that these represent real numbers. So we have to make two assumptions. There's an ordered pair out there that's going to solve them, and B, we're talking real numbers only. Okay? All right. All right? So, since both equations are assumed to be true, and also since x in both equations stands for the number that will satisfy both, x is going to stand for a number that satisfies both, we can replace the variable in x in equation A, the first one, with the equivalent expression for x given by equation B. What does that mean? See that this says x equals?
Mm-hmm.
See that? This is what we do. I just want to break into this is how we do it. Anyone?
This is how we do it.
Kind of. All right. So, do you see what I just did?
You pushed them together.
I took this whole piece and put it here because of the x. Because this says x equals, right? So instead of saying if x equals 2, we would put the 2 in here, right? But we said x equals minus 3y plus 11. So we took that whole equation and we snuck it in there because it says x equals. It tells us that. Does that make sense?
Yes.
Okay, I don't want to lose you, so if you already lost, speak up so we can work it out. All right, if no one's lost at this point, now we solve it, because how many variables do I have left now?
1.
I only have one variable. Okay, so let's solve it. So use the distributive property, that's negative 6y plus 22 minus y equals 1, right?
Mm-hmm.
So that is negative 7y plus 22 equals 1. With me so far?
Yep. So it's negative 7y equals
21. So y
negative-
equals 3.
negative
Okay, negative
y equals
7y
negative 3.
equals negative 21. Y equals?
Negative 3.
3.
Oh, wait.
Y
yeah,
equals
they're both
positive
negative.
3.
They're both negative.
Okay, we're halfway home.
So we know what the
We know what y is. We don't know what x is, but we can find that out pretty easily. All right, so let's take the 3 and put it in on this one, because that's the easiest of the two to do. Okay? So what is negative 3 times 3?
Negative
-9.
Plus 11.
2.
2. So x equals 2.
X equals 2.
Yay.
Now, certainly you might want to check that out to make sure that that works. How do you check that out?
Add it to the first one.
2 times 2
4.
minus 3.
1. 1 equals 1.
Okay? That's how you do it. You just plug in your numbers and check it. What do you think? Easy? They're easily forgotten though. That's the problem with this. People see them and like they get it for a while and then all of a sudden they forget and they're not sure what to do next. Let's do a couple more because they're not always that easy. But here we go. 2x plus 3y equals negative 13 and y equals x minus 6. Now this is a foundation thing because when we do word problems we're going to be using substitution a lot. And another thing called elimination, but we're not doing elimination today. All right, so now we're going to solve for y, right? Well, actually, we're going to solve for x, so we know that y equals x minus 6. So that's 2x plus 3 times x minus 6 equals negative 13. Right? So that's 2x plus 3x minus 18 equals negative 13. All right, so 5x minus 18 equals negative 13.
X equals 1.
5x, yep. 5x equals 5. X equals 1. Now that I know that x equals 1, y equals, so plug the 1 in here, y equals,
5.
which 5?
Or negative 5.
Negative 5. Okay? Okay. Test your theory. Make sure it's right. Plug it back in the first one.
2
plus
15.
2 minus 15 equals negative 13, and that's true. Right? All right, so just plug it in. You want to check just to make sure you didn't mess something up. That does happen sometimes. Does that make sense? Okay, let's try another one. Minus x minus 2y equals 4, and y equals minus 3x plus 8.
Do you put the second part into the first one?
Right.
So,
Minus x minus 2 times minus 3x plus 8.
what happens to that y though?
So you
It's
plug
gone
the
because
It's
that's
gone
what y
because-
equals.
All right, remember I said, because we're assuming, Caleb, that there's an answer to this problem. So y is going to equal the same number in both of them. So since we know that y equals this, we plug all this in for y to stand for y, right? If we're using that substitution axiom, we can substitute, if a equals b, we can interchange them, right? Same type of thing. Does that make sense?
Yeah.
Good. Please speak up. Can't help you if you don't speak up. So as long as it makes sense, we're good. So minus x plus 6x minus 16. Did I do that right? You check me. Make sure I
What
did.
if you
Right.
forgot the
I got
equals
that.
4?
I got that.
Oh, I forgot to equal 4. Thank you. See? I make mistakes too. So you get 5x minus 16 equals 4. 5x
X equals
equals
4.
20. X equals 4. Very good. So now that we know that x equals 4, plug it back into this one. Always pick, you can do either
Negative
one.
12 plus 8, so it's y equals minus 4.
Okay, y equals negative 4. Okay, so you got 4, negative 4. Check it. So that's negative 4 minus, or actually plus 8. So 4 equals 4.
Yep.
Okay, that's just how you check it. You want to make sure you check it. It doesn't matter which one you use to check. You got to kind of pick one. Which one you think is going to be easiest for you to deal with. If you want to do this one, that's fine. That'd be negative 4. Negative 3 times 4 is negative 12 plus 8 is negative 4. All right, so it'll work either way. You kind of have to pick. Let's do one more.
How do you choose which one you put first?
Either
Either
First
one.
in order of pair.
What?
Which one do you put first in order?
X is always first.
Okay.
In an ordered pair, because remember, it's like a graph. X is always the first number. All right, that's how you choose. There's no choice. X is always first. It's for a reason, so you never, ever, when you're making a graph, confuse it, because X is always first on a graph. All right, so it avoids confusion that way.
Okay.
So yes, there's no choice. So 2x plus 3y equals 5, and x equals y. Which one do you want to solve for? X or y? They both equal the same.
X.
You want to solve for x?
Yeah, why not?
All right. So that's 2x plus 3x equals 5. That's 5x equals 5.
5, x equals 1. So that means y.
That means y has to equal 1 as well. All right? So the ordered pair is 1, 1.
5.
But then if you had just solved for y, it would have been the same exact.
It would have been the same one, because yeah, you solve for y, you plug in y here.
And it would be 2 plus 3
Right.
equals 5, so it's true.
Does that make sense?
Yeah.
Substitution is not too bad. It's usually what happens is when we get to elimination and we're doing it a whole different way, there's a different way to do these, that's where we start getting, okay, I don't remember how to do substitution now because we just did elimination. But you'll get some time on substitution before we even try elimination. All right, any questions? Sweet. Nice job. Good work.